Thanks for watching my video today. Let's discuss this infinite sum from k equal to 1 to infinity sine kx upon k. Okay. Now in this I'm going to use c plus is method. Okay, where c is nothing but the cos. Okay, and s is the sine. So let our s equal to, since this is sine, so let s equal to sum from k equal to 1 to infinity sine kx by k. Now if you split this summation, when k is 1, okay, sine x, plus when k is 2, 1 by 2 sine 2x, right, plus and so on, right. Now we have to assume that c is equal to same thing, okay, sum from k equal to 1 to infinity cos kx upon k, which is cos x plus 1 by 2 cos 2x plus 1 by 3 cos 3x plus and so on. Okay, now since we are going to use c plus is method, c plus is, right, c is nothing but cos x, right, this cos x plus I is, you have to add I, s is for first term, okay, this first term and first term must be equate, okay. Now this, okay, second term is 1 by 2 1 by 2 common 1 by 2 cos 2x plus I sine 2x, right, here s should be multiplied by I, right, and plus 1 by 3 cos 3x plus I sine 3x plus 1 by 4 cos 4x plus I sine 4x and so on. Now we are going to use the Euler identity or Euler formula, okay, e to the ix equal to cos x plus I sine x, right, which is exactly the same, cos x plus I sine x, right. So c plus is e to the ix, in place of this e to the ix, okay, plus 1 by 2, this guy will be e to the 2ix, right, plus 1 by 3 e to the 3ix plus 1 by 4 e to the 4ix plus and so on, right. Next time will be 1 by 5 e to the 5ix and so on, it will go on, right. And what is this series, right? Let's consider our log of 1 minus x is minus x plus 1 by 2 x squared plus 1 by 3 x cubed plus 1 by 4 x4 plus and so on, right. You can see, okay, the proof of this. I think this I haven't done yet, but in this log 1 plus x, okay, this one I have already expanded. If you replace x by negative x, then you will get this series, okay. So or above series is exactly the same as this one, right. Here x is nothing but e to the what, ix, right, or x is e to the ix only, right. So c plus is is, since this is minus, so transfer here, minus log 1 minus e to the ix, right, or x is e to the ix. So equation 1. Now similarly, if you do for c minus is, just like that, you come out with minus log of 1 minus e to the minus ix, right. So equation 1 and 2. Since what do we want, or what do we want is nothing but s, right, so for sine. So here in these two cases, sine is this one, right, imaginary part, so I have to subtract it, right. If you want for cos, then you have to add only, right. Now subtract 1 and 2, we have, so c plus is minus c minus is, which is c will cancel and this one will be plus, right, 2is, right, and this one minus log of 1 minus e to the ix and minus minus plus log of 1 minus e to the minus ix. Now using the property of log a minus log b is log a by b, right, this one will be first and this one second, log of 1 minus e to the negative ix upon 1 minus e to the ix, right, and 2is is equal to log of 1 minus e to the minus ix over 1 minus e to the ix. Now multiply both numerator and denominator by e to the ix, right. Now e to the, if you multiply this e to the ix and e to the ix into e to the minus ix is just 1 upon, in this denominator we are not going to multiply, okay, with this one, with this. Instead we are going to take this minus sign common, okay, minus sign common here. If you take minus sign common, this will be first and this will be second, like this, right, minus 1 by e to the ix, right. So 2is is log of, so these two will be cancelling out because same, right. We are left with minus 1 by e to the ix, which is log of minus this one, if you come up here, e to the minus ix, right. So this one we are going to use log property again, then is log of AB equal to log A plus log B. Okay, this property. Right, this I can keep here this one to be negative 1. Right, minus 1. So log minus 1 plus log e to the minus ix. 1 is minus 1. Minus 1 is same as e to the I pi, right? I think. Because this is the, we said that this is e to the ix is e to the I pi is minus 1, okay? And this is the most beautiful equation in mathematics, okay? So I have done this also, I think. So log of e to the I pi plus, in place of minus 1, e to the I pi, okay, plus log of this one. And since this log is our natural log, so exponent with e is, will get cancelled out, right? These two cancel out, meaning I pi minus, y minus, this is minus ix, right? So I common, so common taking out I pi minus x, right? And next step will be here from the last, okay, 2is is equal to I pi minus x, right? So in this I is common, so I cancel out, 2s is equal to pi minus x, so s is equal to pi minus x upon 2, right? One is or s is nothing but or infinite sum to be final, right? To be final, so or s is this one. Therefore sum of k equal to 1 to infinity sin kx upon k is equal to pi minus x upon 2. So this is the whole proof using C plus IS method, right? So we can use for complex also. In place of this sign, you can substitute this one, right? And solve that problem, and after that you have to extract the imaginary part, right? Just like we done before, okay? So that's it.